Good morning, everyone. We're about 3 minutes out from our official start time. My name's Jim Czuprynski. I'm going to be your key presenter today. I also have Jean Eam from Oracle as a panelist as well, and she's going to be helping looking through the Q&A. So as you have questions today, please use the Q&A button at the bottom of your screen and not the chat. Or if you put it in chat, be sure you put it in Q&A. But we'll get started here in just a few minutes, okay? I'm going to start sharing my screen so you can see what we have. And I'll see you in just a few minutes. In case you're just joining us, we're going to get started here in just about a minute and a half. We'll let some more folks join in. We are recording this, of course, and that recording will be available later for your colleagues that may have missed this. And the slides will also be available. All right. Good morning, everyone. Hope everyone's doing well. My name's Jim Czuprynski. I am going to be your guide for our topic today, create uber fast maps. By the way, that's a joke. You'll understand why later. With 23 AI, vector tiles, and H3 indexing. I am entitled with Chief Storyteller. Uh, you can see me here in my full regalia of storyteller. How did I get that title? I own the company. I can name myself anything I want. Uh, so you can see me right now for a few more seconds, but I'm going to cut my video because we have quite a few slides and things going on in the background, and I don't want to have my GPU overload on my laptop, which has happened before. It's not exciting. Uh, a little bit more about AnDOUC if you haven't heard of us before. That stands for the Analytics and Data Oracle User Community. We do TechCasts every month. We just had a really marvelous TechCast last month, actually earlier this month from Mark Hornick. Note that we do have the video and the slides from that presentation available for download. If you want to watch it again, or you had a colleague, hey, you missed this one, you can go to any of these that go back quite a few years, even back into the before times, before COVID. And we have an enormous library of interesting information. So this session will be recorded. The slides will be available probably a little bit later tomorrow, depending on when I get it to my laptop. But just be aware, this is the central place that you can come to see all these marvelous tech casts. We have one coming up next month with Dan and Tim Vlamis, Wayne Von Slees. These are all folks that are volunteers on AnDOUC. but are also experts in Oracle Analytics in their own right. And they're going to be talking about the March and May 2025 releases of OAC. And then coming up in July, a really good friend of mine and fellow colleague, fellow ACE director, Craig Schellhammer, is going to do a really interesting session on knowledge graphs in combination with retrieval augmented generation. And that sounds like a fascinating topic. Anyway, you can come here anytime you want to see that. Also, we have a website, obviously, andouc.org. We are penetrating several different social media platforms here. You might even see us out on a few other interesting ones in the next few months. We don't do that much on Facebook and X or Twitter as we used to, but we're everywhere else, especially on LinkedIn, on YouTube, and Blue Sky. We added Blue Sky, I believe, at the beginning of this year. Again, we also take these recordings and put them out on YouTube. You can watch them anytime out there on YouTube. It usually takes about 24 hours after we get started. So that's all about AnDOUC. Who am I? Well, as you can see from those pictures in the middle, I am not a lifelong athlete. All right. Yeah, that picture, by the way, of a guy, that's not a real gun. All right. That's a training weapon. That was actually taken in a dojo in Israel. The guy that was training me trained the guy who trained the guy who trained the guy who opened our Krav Maga dojo here in Illinois. So I had a chance to work with him. He taught me a very interesting lesson. He said, I know 154 ways to defend against a knife attack. I teach 3. And I thought that's really appropriate for IT, right? We've got these marvelous tools on our tool belts. Most of the time, we rely on just a few. If you want to follow me, I've written a bunch of articles, probably 120 to 130 articles over time. Easiest place to get me if you have questions after today is jim@jimthewhyguy.com. I'm out on Blue Sky. I am banned from Twitter. They won't tell me why, and I don't care. And the best place to reach me is LinkedIn. You can always find me out there. Anyway, enough about that. Let me tell you a little bit about the ACE program. I may have mentioned I'm an ACE director. The ACE program's been around for many years, I think at least 25, if I recall properly, and it's gone through a lot of changes over the years. But the thing is, I'll tell you a true story. I had a colleague of mine who's been doing a ton of blog posts and technical articles and stuff. And I said, have you just thought about becoming an ACE? Oh, I'm not so sure. I'm not that experienced. I said, you could probably become an ACE associate with the skills that you have. He went out there, you could apply yourself as an ACE associate. He had ACE associate in 2 weeks. Now, to get to pro and then to director, it simply takes more involvement in the community, but it's a chance to meet at least 500 people across the Oracle community who know their stuff. There's only about 75 ACE directors in the world. I'm very humble and proud to be part of that group. I just do more than associates and pros do. That's what it comes down to. And the idea here is there's a point system. As you do more and gain the acknowledgement of the community of ACEs, you can move up the ladder if you so desire. There's no pressure on you to move to pro or director, but if you'd like to, it's an excellent opportunity to enhance your career. So please do consider it. Take a look at ace.oracle.com. I've been an ACE director now for, I think this is my 12th year as of this year. It's been an enjoyable experience. Anyway, enough about all that. Let's get into the meat. Here we go. So my topic today is really to talk about something that's not going to go away. There's an old saying in the environmental community, there is no planet B. One of the major changes in the past 10 to 15 years has been the rise of alternative or renewable energy. So this is a true story. This is from March. This is in the Wall Street Journal, not exactly your liberal newspaper. Wind and solar overall in 2024 outstripped coal, the use of coal for coal power in 24 states. And Illinois just joined the ranks. So in other words, in Illinois, we get more power from wind and solar than we do from coal power, from coal generations. Another interesting one, just a few days later, the state of California said, we now have almost 50% more EV chargers than gasoline nozzles in the state. Now, that includes people having private chargers that they share, or as you can see in the picture here, actually public chargers. You pay a small fee to actually use them. I actually stopped at that particular charging station, and that's in San Jose, California. It has 24 different high voltage charging points. Also, one thing that's really interesting is I'm not sure what we're going to call them when they're not gas stations anymore, but there are several companies that are now developing essentially, if you will, convenience centers where you can charge your EV. So this is probably the most visible change, the shift from ICE very slowly or internal combustion engines to electric vehicles. And if you're not convinced of that, that picture up there in the left-hand corner, that young guy is a docent at the Kentucky Museum of Coal Mining. The Kentucky Museum of Coal Mining is powered completely by EV. I'm sorry, scratch that, by solar panel arrays. So there's a little bit of irony for you. This is not going away. No matter what happens in Washington, this trend will continue. So let's think about this for a minute. Here's a lot of different resources. By the way, you may have heard several of the larger data center centric companies, including Google. I was just actually out at Moffett Park about 3 weeks ago, and Amazon. I haven't heard much from Oracle data centers, but Microsoft's been talking about this too, is using small modular reactors, nuclear reactors, totally different than the ones that, we're not talking Fukushima or Chernobyl or 3 Mile Island. These are very sophisticated nuclear power sources, but also solar and wind are simply not going away. The challenge is that the renewable energy sites are very unevenly distributed. And I'll show you a map of that because that's really what we're going to get to today, right? This is an excellent use case for mapping. What if we decided that we wanted to have energy storage systems? I'm talking about battery storage systems here. One of the interesting things is that we're finding out that the batteries for electric vehicles, after they've outlived their usefulness, by the way, in electric vehicles, are excellent for long-term electric energy storage. They could last, as we don't know yet because they're still new, but some of the projections are 15 to 20 years after electric vehicles can't use them because it's a different charging cycle, right? My Volkswagen ID4, I charge it overnight because I'm leaving here shortly. I charge it rapidly and I deplete it rapidly. But battery storage systems are much different than EV storage. And in fact, there are even companies that are developing alternative energy storage systems like, remember those coal mines we were talking about? Taking a very heavy weight and during the nighttime when electrical power is very cheap, raising a weight from the very bottom. Some of those coal mines are miles deep, right? Or any other mine actually would work, raising it slowly at nighttime. And then during the day, letting that weight descend and capturing the energy because you can generate energy that way. So it's not just battery storage systems, but other types of storage systems. So what we need to do is think, where should we build these storage systems? And that's our business use case for today. And by the way, this is an ongoing challenge. This is not just something I made up. I read the literature quite a bit about this, and it's amazing what people are thinking about. So our solution to our mapping issue, because this is a geographic issue, isn't it, is we're going to gather some data sources for using to demonstrate where these sources are and actually where the EV chargers are as well. We're going to gather those up from public sources. We're going to load that data into a 23 AI database. we will really, I shouldn't say create, but populate SDO geometry objects, because SDO geometry, right, is the object that we can store latitude, longitude, and actually just about any type of spatial information, and then build spatial indexes for them for efficient access and processing. And that light green box at the bottom, that's what's new, folks, in 23 AI. Starting in 23 AI, I have the ability to generate what are called vector tiles, and I'll show you what those are in just a minute, or aggregate data with something called H3 indexes. And the really indexes it's kind of a misnomer because it's really a summary table, as we'll show you that. H3 is really designed for aggregation, and I'll show you an example of that in a bit. Vector tiles are for showing geometry extremely effectively on a map. Now, I can use, or I'm sorry, scratch that, to get access to these effectively using bind variables and other things. I'm going to build a REST API module and serve up the vector tiles as blobs. You'll see how that works in just a little bit. And if I need to, we may not have time to go over this, I can actually cache vector tiles. And we'll talk about some scenarios when we might do that. Here's one just off the top of my head. Imagine that you want to display on a map where all of your company's locations are. Maybe, all the convenience centers that you've built for all of the electric vehicle charging stations. Again, thinking out 5 or 10 years, right? Or wherever your business locations are. That's not going to change very often, right? You could cache those vector tiles inside the database so that the next time somebody asks to see that map, it's there. So this is our roadmap. I've been doing this in a lot of my presentations. I've gotten some nice comments on this. One of the things I like about this is I'm giving you a roadmap so you understand where we're going, right? Because just like anything new, generative AI, vector tiles, where do I start and where do I finish? And I found that this roadmap really helps folks to understand. So let's dive in. Let's talk about vector tiles. This is such a cool concept. It took me some time to wrap my head around it, but once I did, I'm like, this is awesome. So here's the way this works. This is a Mercator projection of the world map, right? And again, Mercator projections really corrupt, if you will, what the surface of the Earth looks like. No, Antarctica is not larger than Asia, right? But it's just the way Mercator projections work. But remember that what we're essentially doing is transforming a globe, right, a sphere, into squares. So imagine we cut these up into evenly sized squares, right? What could we do with that? Well, here's what we could do. Imagine that there are evenly sized squares representing every single place on the face of the planet. If I know which square, and more importantly, which zoom level to look at, I know exactly where something is. And this concept actually is the tiles, as I'm kind of displaying them here. Think about that if you looked at them on a map, they would just be a series of squares. Okay. The technical term is a proto buffer file or PBF. That's Papa Bravo Foxtrot, PBF. I can see these anywhere. Here's another way to kind of think of it. Imagine that Mercator projection is at the bottom of that pyramid. If I'm at the very top of the zoom level 0, there are only 4 squares that represent the entire surface of the Earth. But inside each of those 4 squares are another 4 squares. So that top rightmost square has 4 squares as well. And those 4 squares have 4 squares, and so forth and so on. And by the time I get down to zoom level 17, I'm essentially looking at a square a tile, square, tile, right? Yes, I know. I just went to the tile store. They can be hexagonal too. Yes, I know. I'm remodeling a bathroom in my house. Yes, there's all kinds of tiles, but these are square. All right. So these tiles at the lowest level are about 1 meter on a side. That's the whole concept, folks. That's it. It's a Mercator projection, and we can zoom down to the lowest level of the pyramid, if you will. And except for that lowest level, there's always 4 more tiles within it. That's the easiest way to think of it. So how does this work? Well, the nice thing about vector tiles is there's really only one function you need to know anything about. It's called get vector tile. It's going to return a blob. I'll show you what that looks like in a second. That represents what's called a map box vector tile, or MVT. There's also a function called get tile envelope, and we'll occasionally use that to reference an existing vector tile and transform it back into the boundaries of that mapbox vector tile. If I say it slowly, it works. Inside the slides that you'll get, by the way, there's a link to the document that explains this in dramatic detail, but this is the essence of handling a vector tile. It's going to be SDOUtil dot get vector tile. So let's see how we might use that. Simple select statement. But let's take a look at that light blue box. Tile X, tile Y, tile zoom. What are we saying here? Go to zoom level 9. So in other words, go down to the tiles that are at that zoom level. Remember, 4 within 4 within 4. So we're at level 9. Look at tile 129, or the tile that's at X position 129, Y position 187. And what I'm doing is using the EV charging stations table going up to the green box and looking at the geometry column. And what happens is get vector tile looks at SDO geometry and goes, oh, I see. There's a series of points stored within the geometry, SDO geometry data type column. Please figure out which tiles they would be in. Oh, and note that SDO string array. Huh? What's going on there? I'm pulling other column names. The city, the state abbreviation, the longitude, and the latitude of any points that are inside that table. And what comes back? Well, gobbledygook. That's a technical term, right? I don't know where that word comes from, but basically it's just a mess of junk, right? It looks like that. But did you notice there's a couple of clear words in here too? Those are the attributes. The rest of this is the vector tile. So can I do anything with this as a human, right? Is this human readable? Absolutely not. But in a map, I can actually see what they look like. Now, I can also do another thing. Within get vector tile, there's another argument called simple predicate. So let's assume that within that tile, 129, X129, Y187 at zoom level 9, there's stuff from Minnesota and Wisconsin. If I want to throw away everything except Wisconsin, I can pass in essentially a simple where clause where state abbreviation equals, and by the way, there are multiple operators permitted here, but in this case, we're keeping it simple, the state abbreviation of Wisconsin. So again, I have some other ways to essentially prune data out of this mix right off the bat if I want to. One more little bit of code. You ready? Here we go. Let's take a look at this one. Here's a case in that purple box of using get tile envelope. And in this case, we're saying the envelope that I want you to look at is at zoom level 9, the tile at XY 129, 187. I want you to go get that tile envelope And the reason we're going to leverage that is we're going to compare it with other data inside, oh, another table, existing PV, photovoltaic arrays, solar power sites. And we're going to look for any that match up inside that table that are in Wisconsin and these four counties, Dane, Rock, Iowa, and Grant. And we're also going to make a call to another SDO geometry function called SDO relate. What we're saying is, I want you to tell me if there are any points within that county that match stuff in that table. And the one point I want to really drive home is that box in green, that writing in green. What the heck is going on there? One of the things you need to do for SDO relate is pass in a minimum resolution, right? Because basically you're saying when SDO relate is going to look for common points inside the geometry column, it needs to know what its minimum resolution, how low should it look? So here's what happens. Remember we said we start with 4 tiles at zoom level 0? Each tile is 4,000,000, I'm doing the math here in my head, 4,075,016 meters on a side. We divide that by 2 to the 9th because we're at zoom level 9. And then minimum resolution, this is just the way this one works. You multiply times 1/1000th, right? 1/1000. Yes, right, correct. And that defines for SDO relate how close to look, right? In other words, there may be points lower in lower resolution, but I don't care about those. I just care about the ones that would be at this resolution. So this is another example of how you might pair get tile envelope and vector tile. What is this going to return? A bunch of vector tiles. Gobbledygook. Well, this doesn't make sense, Jim. So what? Well, here's what. Let me show you what this looks like. We're going to go to a demo real quickly. So here we go. Here is some interesting stuff. Let me get to the right place. Here is a display, I'll make this full screen so you can see it, of several different things. This is focused on the center of South Central Wisconsin. The blue circles are electric vehicle chargers. The red circles are photovoltaic chargers, solar arrays, I'm sorry. And the green circles are wind towers, right? Wind turbines. This is actually how it's displayed on a map. Remember I told you you take that blob, those vector tiles, and you ship it up to some code to a Mapbox app. And by the way, you can do this in Spatial Studio. I'm not. I'm using something more primitive than Oracle Spatial Studio. I'm actually using MapLibre GL to display this. Here's the cool thing. Any of the code I wrote for this will work with Spatial Studio because underneath the covers, essentially the Mapbox functionality is embedded in Spatial Studio. Well, so what? It's a bunch of points on the map. You ready for this? Watch this. I'm going to zoom out very quickly and look at how fast this map populates. If you tried this with a native map region in Apex, it would run really slowly. How slow? Let me show you. I've got to sign back into my to my Apex app, but I just wanted to share this with you because this is all those points that I just showed you. Let me just grab my password real quickly here. Sorry about that. There we go. Of course, it times out just when you need it, right? That's the art of the live demo in Oracle. I have a little app here that basically shows all of that stuff. Okay, I'll log in again. Thank you, Oracle. I will sign in again. Thank you. Come on now. There we go. Here's a little app that I built. And what I've got here at the lowest level, I'm going to zoom back out a bit to about the same resolution. I'm using a native map region inside Apex to load up those same points. It's about 180,000 points. Notice anything? They ain't no points here yet. It takes sometimes, depending on network traffic and everything else, 30 to 45 seconds to load those points up. That's the comparison that I want to really get to you, right? Understand that vector tiling makes this extremely efficiently. I can talk here for another 30, 40 seconds, maybe even, and sooner or later, some points will begin to appear on this map. But it takes time because finally, same points. I think we even use the same color scheme. Yes, I used blue, red, and green for the different wind turbines and stuff like that. But look at how long it takes for that to load. And it's not really that efficient. Look at this. Look at how fast this loads. And when I zoom into things, how quickly it loads. Folks, this is called a modern mapping application. If you imagine if you were trying to present these points back to something like Google Maps or any other mapping application, you would be out of business, right? Oh, one other cool thing. I happen to know many of these points because I have a little cabin in Wisconsin. You may have noticed that in my intro. And it's kind of hard to see, but there is actually one electric vehicle charger in the entire county, and it's right there. I just I just mouse clicked on that. Oh, it's in Beaver Dam, Wisconsin. It has some level 1, 2, and 3 charger. Where did that come from? Remember when I showed you the code and I said I could pull separate attributes? Yeah, that's where that comes from. Here is a series of wind turbines, not that far from my cabin. Here's its USGS, US Geographic Service case ID. It's located in a town called, I know this one very well, Iron Ridge, Wisconsin. Here's its zip code. That particular tower that I clicked on is 121.3 meters high and generates 1,500 kilowatts per hour. And I can click on any one of these and pop up any of its details. Key point that I'm trying to make here, this is much faster and much more effective in loading. And yeah, I can do similar things here too with a mouse rollover and so forth here in a native map region. But right now, which one would you pick? I'd pick this one in terms of the speed at which it loads. Another really cool feature of this is it's very evident. Remember, green is where wind turbines are. It's very evident in the United States where most of the wind turbines are. And they're mainly in the center of the state. And notice, even down in Texas, right? But not that many up in here. Why here? Because it's wide open plains. If you've been through Nebraska or the Dakotas, you know how the wind blows, right? So that's where, and notice there's a ton of stuff down here in Texas as well. The other really cool thing about this display is that I get an idea of where the concentration of things are. Notice there's a ton of photovoltaic arrays, solar arrays out on the East Coast and in Florida as well, and out in California, but not that many wind turbines. So I get an immediate visual feedback of where to look. Remember what our use case is. Where should we put our battery storage systems? Well, I'll tell you one of the ones I'd certainly look at. How about Minnesota? I mean, look at this. This is actually Minneapolis, St. Paul. I mean, there's some really great places here. Like maybe right here would be a really good location. And that's just looking at stuff visually. So I just wanted to share that with you because it's kind of a cool little tool and some quick feedback on that. I'm going to jump back over to my session. Hopefully you're gaining some appreciation of this. Well, wait a minute. How did you tie all that stuff together? Remember I told you we're going to have to build a REST API for this? Yeah, so it's really simple. I build a module. I build a template. By the way, you can do this inside the REST IDE that comes as part of SQL Web Developer. SQL Developer Web, I forget, SQL Web Developer, uh, you can do it right inside there and define these without writing any code. I'm just showing you the code that actually gets generated when you actually do that. Let's take a look at this one a bit. What are we accepting? Uh, See it right there? X, Y, and Z. Z is the zoom level. X and Y are the vector tile X and Y coordinates within the zoom layer. What's going to be returned is a type of ords.source type media, a blob containing a vector tile. And here's the guts of it. If that looks familiar, it should look familiar. Except notice for this one, right? The table, EV charging stations, use the geometry column as the source for the vector tiles themselves. And then here's a bunch of attribute column names. Remember when I showed you that one I clicked that I said was near my cabin in Wisconsin, and it had EV level 1, 2, and 3 charges of 0, 4, and 2? That's where it's getting that data from. And then we pass the X, Y coordinates of the vector tile and the zoom level here. How do we tie that all together? A little bit more code. This is an example of how you would do it. This is, and by the way, I will be putting out a live labs on this that has all of this code. It's going to be another month or so before I pull that together. But I'm using something, if you can see it here, called Map Libre. It's actually a map box tool that lets me accept the vectors. Here they are that come in. I'm making a call to, if you understand how to call a REST API, right there. That's the ORDS REST API call that lets me get these vector tiles. The layer itself, this is for the EV chargers, uses a blue color, and I can specify some other things, a slightly brighter blue color for the outer circle itself, how opaque the circle should be, and so forth. And then remember I showed you if I click on that, stuff pops up. This is inside the map box tool, the ability to figure out, oh, for this latitude and longitude, there's only going to be one point there. Here is the information for that vector tile. And by the way, I did a similar thing for the wind turbines and a similar thing for the photovoltaic arrays. This code is available under Map Libre. I have a link to it, by the way, and it's super easy to develop. Excellent examples. There's even some really cool stuff you can add there, including the ability to see the scale. You may have noticed that in the bottom left-hand corner when I showed that map. The scale control itself shows up that, oh, you're at zoom level 15. That really means that we're at a resolution of 20 meters, I think it was, or something like that. There's some awesome stuff that you can do. Or you can just do it all in Spatial Studio. It's much easier. The key point I'm trying to make here, folks, is any code you write for this can be used in Spatial Studio. So whichever way you want to go, you don't have to start Spatial Studio, start it up, start the server up, configure it. You can just do it here to test things, and it'll work. Back to our presentation. Here we go. So I showed you how to actually access vector tiles. Super easy to do. I've showed you how to display the vector tiles, right? These are just some other slide examples at different zoom levels, and also showing how you can drill down, or I shouldn't say drill down, but click into a point and see additional information about that particular point, whatever it might be. But we're just getting started. I'm guessing you may have some questions. We'll get to those towards the end of this. We have plenty of time yet. Taking a sip of coffee this morning. Here we go. The other thing I'm going to talk to you about is something called hexagonal hierarchical spatial indexing, or H3 for short. Can't imagine why they acronize that to H3, right? I don't know where the other H comes in here. HH, but maybe from hierarchical? I don't know. In any case, this is another cool feature. This is something else you can do in 23 AI, but it's very different from the Mercator projection. So this is new technology. It's barely 7 years old. What happened is a bunch of engineers at Uber came up with a new geographical indexing system. It essentially is 122 polygons, 110 hexagons, 12 pentagons. And they figured out that this works better than Mercator projections. And here's the way this works. It's still got some things very similar to the way vector tiles work, right? Each hexagon contains 7 hexagons, which contain 7 hexagons, etc. At the very lowest level, they cover about 1 square meter. But why a hexagon? Circles fit really well in the inner boundary or the outer boundary of a hexagon. So why would I be interested in a circle? Because I'm an Uber driver. What people want my services within this circle, within this hexagon? Or likewise, right? Have you had this experience? You're sitting at your hotel, you're running late for your flight. How many Uber drivers are close to my hotel? Bingo. Now, here's the cool thing. Each one of these polygons could be a hexagon inside a pentagon, but in most cases, it's going to be hexagon within hexagon, is assigned a specific value called an H3 key. Here's the cool thing about H3 keys. They are hierarchical. So the idea here is the outermost hexagon knows what other hexagons are contained within it. And those hexagons know who their parent is, and if we're not at the highest or lowest zoom level, who their parents or grandchildren are. And it's built into that key value, that H3 key value. So if I know my H3 key value, I know what my parent hexagon is, and I know who my children hexagons are. And I can use this in a very different way. Can I still use it to generate vector tiles? Yeah, but I can also use it for aggregation purposes. So here are some of the basic functions. In the slides I'll send you, by the way, I've got a lot more. Do you need all of these? Not really. Not really to get started. In fact, the one we're going to focus on for right now is H3 sum as table. Because what we're going to be able to do is, first off, well, I kind of misspoke there slightly. H3 sum create table is necessary first. But once we create it, we can populate it with H3 sum create table and then return rows with H3 sum as table. Why is this called sum? It's about aggregating. Because I'm not so interested necessarily about just the points, but about high level information for those points. And I'll show you an example of it right now. So here's one of the cool things you can do with this. Remember, we have wind turbines and photovoltaic arrays, or PVAs, as I like to call them. What if I wanted to say, hey, how many of them are close to each other within this geometry? I could actually calculate for each one of them where they sit. In other words, what's their H3 key? And then join information together based on that H3 key and say, within that same, remember, they're specific to a particular polygon, a hexagon typically, at a particular zoom level. How many of them are within that same hexagon? And here's what I could get from them. If you take a look at the whole query, what I can tell you is at this H3 key level, there are a total of 3 locations. And for this one, I can tell you those 3 locations, right? They could be wind turbines or they could be photovoltaic arrays. I've got a total of 4.2. Now, I believe that's in megawatts, if I remember correctly. And these are in megawatts, right? These are also in megawatts. But between these two, I've got 7.2 and 1980, because I've got more wind turbines in this particular array of power that could be generated. And so why am I doing this? Remember our use case? Where should I put the storage location, the battery storage or energy storage locations? I'm probably going to pick one of these, right? I'm going to pick one and or a collection of them to build the battery storage units because I'm summarizing the total capacity. But wait, there's more. Because I can also build a table. In this case, notice I'm calling a table called H3 sum wind turbines. What am I doing here? Well, it's that cow spec argument that I want to draw your attention to. I want to take existing wind turbines, and I would like, dear Oracle, to create a series of H3 values at zoom level 7 and higher. And what I want you to gather is a count, but also their wind turbines, remember? What their minimum, maximum, and average capacity is. So remember when we looked at vector tiles and we said we could tack on attributes? For each one of these H3 key identified polygons, I would like you to give me how many minimum, maximum, and average capacity. So these are used for aggregation. Let me show you. Once I've got these, what do you think I do with them? I build another REST API, just like I did with the other ones. I don't know if I have, no, I don't have an example of that REST API, but I could share it with you. And what I can now do is actually display these and drill down lower and lower to see information about those tiles. Let me show you live because I have another example and it's right here. So I'm going to zoom back out all the way as far as I can. Here's the entire world, and you can see, oh, okay. Well, I only have data for North America, really for the United States, to be honest. What's this stuff over here? US Virgin Islands. Why are these red, green, purple? I told them to go that way. Why did I do that? By the way, in case you didn't notice it, right there is a pentagon, right? 5 sides. Oh, I'm sorry. Scratch that. No, that 1, 2, 3, 4, 5. That is a pentagon. I got it right. Haha. So there's an example of one of the pentagons. As I drill lower, I'm just mousing in. You'll see that the color changes. Red is most intense. Green is least intense. I simply coded this inside my HTML for the Mapbox coding to say if the range is in the upper tiers, the highest tiers, make it a brighter red. If it's a lower tier, right, not zoom level, but in terms of distribution of values, make it green. If it's somewhere in the middle, make it yellow. If it's somewhere between, in the lower 25%, make it purple. So at this level, I can see, oh, okay, there's quite a few turbines, definitely not in the United States South, and not that many out here in the West. But as I zoom in, do you see what's happening? As I go to a lower and lower zoom level, I'm now at a 300-kilometer zoom level. And as I delve in lower and lower, I can see where the intensities are. Again, bright red is highest intensity. This matches exactly the same way we displayed the points, except we're looking at an H3 summary level. By the way, these are still vector tiles. We're just using H3 to display those vector tiles. And as I zoom in closer and closer and closer, notice that I'm now at a lower set of the vector tiles. So again, this is just a different way of displaying stuff. This is, if you think about heat maps, this is similar to way a heat map looks. But again, this is geographically defined heat maps, okay? Not just squares or not just geographic boundaries, but literally at lower and lower. I'm now at the 30-kilometer range. If you take a look at that little note in the bottom, and when I get all the way down, right, I'm at the 10-kilometer range. And then that's as low as I'm going because I only went down, I think, to about 7 meters on a side, or zoom level 7, I'm sorry, right? So again, I also can say, don't create them for every single zoom level, right? Nobody's going to go looking uh, for this type of analysis at that level. 10 kilometers zoom level is fine. So I have quite a bit of flexibility on how low I can go. Wow, that's a lot to absorb in less than 43 minutes, 48 minutes, actually. Let me jump back to my slides for a few minutes. So again, H3 is for aggregating data at a lower and lower level. And I can determine that the zoom levels can stop at a particular level if I so desire. One last thing, I'm not going to spend extra time on this, but vector tiling. I can actually save vector tiles that are frequently used and cache them inside my database, right? Inside essentially the database buffer cache, essentially the shared pool, right? If you remember, SQL result sets that we could have things that are constantly queried, right? A result set that comes back, we can save it for a period of time. Maybe a list of every single one of your convenience centers across the country, right? There might be only a few hundred of them. I'll query them one time. I'll keep them cached because people keep coming back to their name and address and geographic location. I can do the same thing with vector tiles. Here's an example of caching vector tiles for wind turbines and for photovoltaic array sites. And I can also see which ones have been cached by querying these two views. Here's an example of what comes back from those. I can also see the individual values at that particular level. Here we are again with zoom level 9, tile 129, 187, just to show you that's one of the tile keys that's actually cached. How did it get cached? Because I went after it in my map. And since it was used several times and I've enabled caching for it, that one in particular is cached. I can also purge the tile, vector tile cache. I can disable it if I so desire. And I can even enable other schemas to leverage that vector tile, right? So all my schemas were under HOL 23. I can also enable the GeoSwarm schema to leverage that vector tile, even though it doesn't own any of the data. And I could also revoke it from a particular schema. Hey, don't cache these ever, right? We don't want to cache them for HOL 23, just as an example. So to wrap it all up, vector tiles, an extremely fast display. Remember, I showed you the native map region in Apex just to show you a not very efficient way of displaying things. Here's an example of modern map applications. H3 indexing returned, don't forget, vector tiles. But their focus is on aggregating data, right? And being able to zoom in and out and see, where are the concentrations within that? Remember, H3 indexes or H3 indexing returns, bottom line, still vector tiles. So again, if I want to focus on point clouds, vector tiles by themselves. If I want to focus on aggregations of information about those points, H3 indexing is probably the way to go. You can hit them from Mapbox, as I showed you, Mapbox HTML JavaScript. Very simple to write. I have links here for examples of them, and I'm still playing around with them. I'm trying to do things like enabling and disabling different layers via a simple couple of map clicks. There are tons of unbelievable features. The same features for Mapbox HTML can be used in Oracle Spatial Studio. And I've been chatting with the people over at Oracle that develop spatial and graph technology. And the rumor is, again, you didn't hear this from me, but in a future release of Oracle Apex. In addition to native map regions, we may be starting to see these features appear in Oracle Apex applications as well. I mean, don't get me wrong, native map regions are wonderful things. They are really cool stuff. But right now, the only way you can access vector tiles is through Spatial Studio. You could also, by the way, if you wanted to, if you developed it in Spatial Studio, you could access that frame within Oracle Apex if you know how to access stuff in Oracle Spatial Studio in a similar fashion, but not natively, not yet inside Oracle Apex. I keep crossing my fingers that's coming. I have some really cool links here for you as well on H3 indexing, vector tiling. There's some really excellent blogs here that the Oracle Spatial and Graph team have built. There's a really neat Ask Tom session on it as well. I also have some of the other information about using Mapbox.gl. There's some really nice JavaScript guides and examples. That's where I got most of my code examples from, by the way. If you can't get to sleep tonight and want to learn more about H3, go read that blog. It's actually kind of fascinating how they built this. That's where I got some of the images, by the way, really nice. And you can actually look at a live demo of H3 in JavaScript with that link. And then finally, just a few other pieces of interesting information about EV charging and wind and solar power. If you were curious about it, you could take a look at that. And then finally, some helpful links about everything else about Oracle Analytics and Oracle AnDOUC, our user group. And finally, don't forget, this will be shortly available to your colleagues in the future. We'll be posting this one later today or tomorrow, and also on YouTube. And don't forget, June 26th and July 24th, we have some other interesting topics coming up. At that point, I'm going to actually take a breath here and see if anyone has any particular questions. I see a bunch of stuff in the chat. Thanks, Jean. I presume that Jean Im was on the call with us today as my fellow panelist, and she pasted a bunch of really good stuff in here. Please take a look at that. There's some really neat information out there. Thanks, Jean, for doing that. And thanks, everyone, for coming. I am not sure that anyone had any other questions. Jean, my fellow panelist, anything else you might want to chime in on?
Yeah, so thanks, Jim. Great presentation. On the Q&A, there were a couple specific questions. Shout out to my colleague, David Lapp, for chiming in on and advising on some of these responses. So, Jim, I think we addressed those, but there was a question about the possible range of values for the zoom level in a vector tile, and David confirmed that that is consistent with the Google tiling scheme with a maximum of 22 with a range of 0 to
22. Okay.
Yeah.
Okay. I think I said 17, but I know where the 22 comes from. Yes, now that you mentioned
Yeah.
it. Right.
Yeah. So I guess
Yes.
that's what's possible. Yeah. Yeah.
Okay. Okay. Sorry about that, guys. If I had the wrong number, I apologize.
Yeah, no worries. And then Jim, there was someone interested in whether vector tiles work with polygons as well. And so I know that David has confirmed that indeed vector tiles do work with polygons as well as lines and any other comments?
Yes. Right, right. No, you're exactly right. In fact, some of the examples in the documentation from Oracle for this, right, Gene, actually just focus on here's how to create vector tiles of polygons. So yes, absolutely. Absolutely they do. Right. I was more focused on the point cloud aspect of this, but absolutely. Yeah, I barely scratched the surface on what you can do with vector tiles.
Yeah, cool. And Jim also, not a question, but David has also pointed out an interesting comment on the Q&A that you'll see if you take a look at that.
Yeah, let me go take a look at that real quickly. I'll stop sharing here. We don't need to do that anymore. Let me just take a look at the Q&A real quickly. Spatial Studio maps can be embedded into Apex using a native web component. Okay, good. I did mention that. Thank you. Gerald had a question. Can tiles be stored on a mobile device? Ooh, that's an interesting question. Um, I'm not sure what we mean specifically by stored, but you can certainly display them on a mobile device if that's where you're going with that, Gerald. I wasn't sure. Uh, Again, since this is essentially a web browser, right, folks, it doesn't really matter what device you use to access it. Uh, Okay, for use in a disconnected application. That's a great question. Gerald, do me a favor, and if you could shoot me a note at my, I will drop into the chat my, or actually in the chat, let me drop my email address in there. And if you could send that over to me, I would really appreciate that. Let's see if I can type this morning. I'm going to drop that in there. Folks, if you do have questions, go ahead and drop that into me at that email address, and I will be more than happy to follow up on that. And David, thanks so much for jumping on there. I'm sorry I didn't have time to make you a panelist today. That would have been a really good idea. Um, let's see, anything else? Scanned raster data I see coming in from Daniel. Um, hmm. Daniel, drop me a note, please, and I will get back to you. Folks, anybody else have a question on that? I know I threw a lot at you. Uh, I'm just really excited about how that works. Daniel also asked, how hard is it to get scanned map data that changes continually into a vector tile database? That's another good question. Um, I noticed that David has answered that as well. You can generate vector tile in database and push them out to a SQLite DB. There you go. There's a great way of handling it, right? Um, Again, the vector tile concept is not really limited to just Oracle, right? Anything that has, as I understand it, at least a geometry data type or anything that can generate a vector tile. I believe we can even do it in come on, Jim, think. What's the other database that Oracle owns or is responsible for? Hmm, our other SQL database, MySQL.
Right.
I
I
believe
see.
you could do it in MySQL, right? Yes, thank you. So that would be another one. I've not played with MySQL and geometry data types, but that certainly should be doable. So yeah, we're not just Oracle centric here, folks. We're we're definitely thinking that MySQL would work fine. And again, you'd have to somehow develop the REST API connections to use it. But again, REST is REST, right? Okay. And we don't have vector tile generation apparently in MySQL, unfortunately. David's responding. Oh, these are great questions. Anybody else, folks? These are great questions. I seem to have poked a nest of friendly bees on this. Okay. Well, we're coming to the top of the hour. In fact, we passed the top of the hour. Gene, David, thanks so much for jumping in on that. I really appreciate your insights on this. Uh, Please, folks, if you have questions, I did embed my email address there. I will get back to you, I promise. I just find this a fascinating topic, and thanks for coming. This has been a great Q&A as well. And like I said, we should have the recording of this out later today. The slides are ready to go already. I will get those posted as soon as possible. And with that, I think we'll be wrapping up. Gene, did you have any other comments as my co-panelist here?
No, thank you, Jim, for another outstanding presentation and for bringing this topic to life. It's fantastic.
Absolutely. Absolutely. Well, thanks everyone for coming along today. Have a great rest of your short week. And we'll see you again. Don't forget, June 26th, we have sessions on Oracle Analytics Cloud. or yeah, Oracle Analytics Cloud for the May and March releases. See you all then.